Hello, hello, hello. Can you hear me, guys? Please reply yes or no.
Yes, sir.
Okay, thank you.
Yes, sir.
So, 1 minute. Can we start or wait two
Yes,
minutes?
sir.
So, can we introduce one by one? Let
Good
me.
evening, sir.
Yes, yes, please.
I'm Madhuba. I'm Madhubala. I'm studying third year of physics at Bishop Heber College, Tiruchirappalli, sir.
Okay, nice.
Hello, sir.
Yeah, name
Sir,
please.
this is Bhuvan Bandar PA from Karnataka.
Mm-hmm.
I'm in first year of MSc in physics.
Okay, very good. Next, any other?
Good evening, sir.
Good evening.
My name is Samir Ahmed. I am from Karnataka.
Okay, and
Final year student, mechanical engineering.
okay, nice. So let me introduce by myself. I am Harishankar. I am a PMRF fellow at IIT Roorkee and under the joint supervision Professor K.L. Yadav and also Professor Ashish Garg. So this is the first assignment solution on solar photovoltaic. We will discuss here 15 questions and also the concept regarding this. Okay. If you have any doubt, any voice problem, something, you can write in chat box or you can directly unmute and call me. Okay. Be interactive. So let's start. I think okay, 6 is now. So let me discuss first solar irradiance. So do you know what is solar irradiance? You can see in picture. What is this? You can see this is taken from Wikipedia. You can read this. Solar irradiance is a power per unit area. What is this? Power per unit area receiving from the sun in the form of EM, electromagnetic radiation. Okay, so this is the a unit of this watt per meter square in a unit. Also on other units you can see. And irradiance earth surface additionally depend on, this is dependent, but dependent on what factors you can see one by one. Slide 1 minute. So in video which is uploaded in NPTEL, do you see, did you see these slides? or this video
Yes, sir.
okay, so this is our professor is discuss solar irradiation fundamental. What is this concept? Is sun is reaction is there, 4 hydrogen 2 electron make 4 helium, and this much is amount is energy 26.7 megavolt. This is huge. And sun is consist of 90% H2 and 9% helium, and 1% is other elements. Okay, and also we can see amount of energy we get, variation in the energy spectral temporal variation with time. We can see one by one, and this is the geometry concept like that. You can see sun temperature is 20 to the power 6 Kelvin at core level, and coldest part is black body. We can see 5800 Kelvin coldest part, outer space. Let me take another chart. Okay, and is air is our earth. Distance is given, and this is the angle which is formed by sun and earth. So that much energy, rate of energy emission from the sun 3.8, and intercept on the earth that much. So energy, if we incident on an object, this is the concept. What it is? Incident energy is reflect, transmit, and absorbed by any material. So some of these should be 1. And another variation with angle dependent. What is angle of incidence? This is. So angle of incidence 0 to 30 is maximum, then decreases. And solar radiance value, Mercury has the highest, then Earth, then distance is, this is distance dependent factor. Okay, so these are the concepts. And solar constant H, we know this is the formula. So, and also please see, this is the expression radiant power density outside the earth. We will solve the question on this concept in next slides, but we will, let's see first what is the sir has taught in class one by one. Affecting solar radiations is absorption, spectrum, or reflecting, and also these atmospheric local variation, latitude, and absorption at 18%. And then you can see in percentage form. Okay, direct, indirect, variation, output. So I am recap this from the lecture, then we will discuss question. Okay, please see carefully also you. So global radiation, let's focus this term. This is useful for us. What is global irradiance or radiance? AM 1.5 G. What is meaning G? Global radiation. So global radiance is the sum of direct, ID, and indirect. Okay. So sum of total radiation, direct or indirect, called is global. Term is global. And what is AM 1.5? We will discuss in and with question. But you can see in the picture that one, the angle substitute by, this is the air mass coefficient equal to 1 plus, this is length shadow divided by height square whole root equal to the 1 upon cosine z. So these are the another concept: intensity with the function with AM and relation. So let me come to the question. I think this is definition almost. So let's see picture. How we measure the global radiation? So we will use pyrometer, okay, for this, and direct normal irradiations measured by perielementary meter, okay, mounted on the solar tracker. So let's see the this plot. What is this? Called is spectrum of solar irradiation on Earth. So x-axis is represented by wavelength, you can see, and y-axis is irradiance, watt per meter square per nanometer, according to the wavelength. What is this? Watt per meter square? So let me ask one by one. Where is the maximum irradiance in which range? In term of wavelength, please. Anyone please tell me. Yes, please. You can 250, 500, 750, 1000 in nanometer range. Where is the maximum irradiance? You can see maximum. Let me there. This range. Yes or no? This is the highest point of y-axis at y-axis. Yes. So in the visible range, this is called visible range, we will get more irradiance. So if we use this spectrum or by any material use absorbance this light, we will get more output. If input is high, output also is high. If we material, let's say I have a material, use this spectrum most and want to maximum output. So for solar cell, let's say for solar cell, if we absorb total input and convert electron hole pair efficiently, collect by outer circuit or electrode, we will get more output. So we want to use this spectrum. So any material, if I have a semiconductor band gap, let me 1.5 electron volt. So what is the wavelength according to this energy? Let me ask simple question. Material has a band gap in 1.6 and energy incident on this 1.5 eV. This is useful for this band gap material or not? Can this material absorb or not? Anyone, please? Incident light has a energy 1.5 eV and material bandgap semiconductor 1.6 eV. So this is incident light absorbed or not by material? Yes or no, please? Anyone? When material is absorb light or when is not? What is the physics behind? This is valence electron, valence band. Let's say this is conduction. This is conduction band. This is valence band. So we want to electron jump from air to air. So how much energy is required? Let's say band gap has 1.6 electron volt. Please tell me. You can write in chat box also. Minimum energy required.
The incident energy is greater than or equal to 1.6 electron volt, then the electron will jump to conduction band.
Yeah, very good. So this is the concept when if incident energy less than the material band gap, material doesn't absorb. Okay. If only if absorb material if the incident energy is greater than or equal. Okay, so we will see question on this. First, this is the useful term in solar photovoltaic, air mass coefficient. So how we can define? Let's see the definition. This is the definition. Path length taken by the light through the atmosphere, which is normalized to the shortest possible path length when the sun is at zenith. Okay, so quantification of loss of incident irradiation use dust, etc. This is another term. So air mass coefficient is, let's see in picture. When sun is at zenith, and this is shortest part. Yes, and let's say this is 1 p.m. This is 3 p.m. After some time, sun is moving around with respect to the earth. So this is path length taken by the ray is larger than the 1 p.m. Okay, this is y, this is x. So this angle is known as, what is this angle? Anyone know? What is this? So we will discuss also the angle. Okay, so first air mass coefficient equal to the, remember this formula, 1 upon 1 upon cosine z, 1 plus highest, so, or let's say this diagram taken from previous, I think. Yeah, z and height. Okay, so please calculate one. Let me ask one question. AM 1.5. What is the angle corresponding this? Please find. Can you find? So put 1.5 equal to 1 upon cosine z. Now we can solve. Please tell me. Solve this equation. 1.5 equal to 1 upon cosine z. You have a 2 minutes for this. Simple, you can use calculator. Are you trying to solve?
0.99.
In what, radian or degree?
Degrees.
No, I think is something is yes. Let me. Can we convert like that? 1.5 and take inverse, cos inverse of this much. Now find
48.189.
48 point.
48.1.
Yeah, very good. So you can see here answer is also given. Q or Q, let me Q 48 point around approximate 0.2. So you can find the angle, use this formula. Okay, if in exam question asked like that, please find the this and 1.5, 1.6, 1.7 am like that. So you can easily find the theta. Okay, use this expression and also remember this definition. Yes, so remember the also this expression, these terms. M0 is, what is this AM0? The spectrum outside the atmosphere approximate by the 5800 Kelvin black body is referred to as AM0, meaning zero atmosphere. What is this meaning? Zero atmosphere. Useful for outer space applications such as satellites. And for solar cell, this is the useful term. What it is? Let me highlight this. Let's say I have two solar cell. How I can compare? So what is the reference for elimination? Reference elimination is AM1.5 spectrum. You have to use a spectrum which is referred as AM1.5. So whole world, to measure the efficiency of any solar cell anywhere, use this much amount of irradiance, AM1.5. So we can compare easily anywhere two solar cells. Okay, so let me ask first question. This is your first question. The factor influence the solar irradiance on Earth's surface is which is most affecting absorption, scattering, day of the year, wavelength of radiation, type of receiving surface, and time of day. Read this question carefully and let me show you two slide previous. Then you can. I will give hint previous. Okay. You can take a screenshot or you can write. So let me show you. Absorption is 18%. Another is scattering. You can see, and direct to the available for Earth is 70%. Okay, and similar way you can think another option for. So which one is correct? Anyone? Let me show you answer. D is the answer. Please now think. Time of the day. This is, let's say, Earth. This is, so time is, let's say, 1 p.m., 3 p.m. So time is important or not for in time of irradiance by the sun for the Earth. Time is most affecting, yes or no? Yes, please. If you have doubt, you can ask. If you don't have, then you can write in chat box yes. So in atmosphere, let's say Earth atmosphere, absorption is always is there. for any time, but time is what time at which we measure is most. Yes, so then absorption, then scattering, and wavelength also, and day of the year, and type of the receiving surface. This is the order affecting the irradiation on Earth. Clear?
Sir, what's my day of the year?
Huh?
Day of the year?
Yes, day of the year we will like say 29 June or 21st. So this is also tilted Earth rotation. Something is we will see. Okay.
Okay, sir.
This day what happened? 21st June. So day also depend.
Okay, sir.
Our Earth is also tilted. So solstice, we will discuss in
Sir.
next slides. Okay.
Okay, sir.
Okay. So this is the order. And next question: solar radiation is measured in SI unit. Please, you have to answer all guys. If you listening,
Watt per meter square.
yes. Any other? Please also write in chat box. Option A, B, C, D. For second question, please answer in chat box all. I am requesting to all member. Please answer. Write in chat box. Okay. So answer B is correct. Let me show you. This is the SI unit for radiation. We have already seen in curve watt per meter square with respect to the wavelength in nanometer, like that is spectrum. Okay, let's move for next question. Yeah, this is the good question. Calculate the approximate solar irradiance value for Earth and find the correct answer. How can you calculate? Let me give to you formula, then please solve. H naught equal to radius of sun, distance between Earth and Sun, and H, what is this? Stephen Boltzmann constant. So let me write R sun 6.96 10 to the power 5 kilometer, and distance between Earth and Sun that much 1.5 10 to the power 8 kilometer. Okay, and what is H? H equal to also, this is Stephen Boltzmann constant, This is sigma 10 to T to the power 4. What is temperature for surface? Option outer surface. That much. Okay, answer is correct, but please calculate. I think you remember answer, but how we can calculate if I changes the parameter. So please see the procedure. What is sigma? This is constant minus 8. Unit also is important. Watt per meter per Kelvin power 4. So you have all values. Now you can calculate. You have 2 minutes for this question. Please solve. B option is correct, but please solve if you are able or not. Put all these value in this equation. You will get approximate this answer. Okay, so this is the homework for you. Please solve. Right. So next question. Which of the following optical design factor requires for the solar panel to be installed an optimal angle to the horizontal surface? Any idea for optical designing? So let's say I have a material. Let me give you hint. What should be the maximum? Let's say light is incident, absorption, transmission, and reflection. Let's say this is our solar cell. Other please answer. So our solar cell should be the absorbed incident light is maximum, so that we will get most or higher output. If absorption is higher, then electron hole pair generated is higher, then collection will be also higher. If solar cell is defective less. Yes, so we can see maximum absorption and minimum transmission and reflection losses. This should be the minimum and this should be the maximum. If the material absorb all light, then output also is high. Okay, next question. The value of zenith angle at air mass 1 is. Please calculate all member. all participants this question. Let me write formula. M equal to 1 upon cosine z. This is zenith angle. Okay, and define how. Please calculate this expression. We have already solved this type question. B, okay. Other, please. Am equal to, you have given 1 and 1 upon cosine z, cos z equal to 1 and inverse of cos z1. What is this? What will be the answer?
0.
Okay, nice. So this is easy. Clear to everybody? Okay, almost. I think it's done. B is right. This is definition also. Next question. The value of the solar declination angle on June 21 is. Answer is B, but calculate. This is the formula. What is, you can see in slide. Please write this formula for declination angle. 23.45 degree sine of 360 divided by 365. You can use this. Okay, please use this formula. So what is n here? Anyone? Please find n first. And how? Please tell me first n. What is n? For June 21st. 21st. So let's say Jan first. Jan first represent n equal to 1. Now calculate. June. Okay, 181. So use this in this equation. You will get the answer. So remember this expression also. Okay. So now please find the answer. N equal to, how we can calculate January, February. This, let's say this is 2025. In year of June 21st of 2025. January, February, March, so you, in this order you can calculate. Please, I am waiting for your response. What is answer? Okay, are you listening? So January, February, March, April, May, June. Calculate the number of days. Let me, sorry, wait. N equal to, from January 1st, N equal to 1. So January how many days? 31st, 31 days. Then February, then March, how many days?
31.
Then April, then May, then June. In this way you will able to find the number of days up to 21st June.
Okay, sir, I
Clear?
understand.
Okay, so 171.
Thank you.
Okay,
Yes, sir.
okay. Use this in formula, then you will get the answer. Please solve at your home. If you not get the answer, we will discuss in next class also. Okay, so let's discuss next. This is the question. Calculate the available energy range for visible solar spectrum. Visible solar spectrum. Where is the visible spectrum? You can see this is visible. What is wavelength? Available energy. So you know the expression. Equal to Hc by lambda. Yes or no? And
Yes, sir.
easy. And put this constant value. Let me this is nanometer. This is in electron volt. So let me first lambda for visible. What is? Let 400 nanometer, and this is minimum. Lambda max, you can take 700. Okay. Now put lambda in this equation. Please solve. What is the value? In electron volt. And if you use 700 nanometer, this is what it is. 1.7 around in electron volt. So this is the expression equal to h nu or hc by lambda, and constant of this value hc in electron volt, you will get this 1240 lambda in nanometer, and energy will be in electron volt. So if you have a lambda, you can use this expression 1240 divided by lambda in nanometer, energy will be in electron volt. Clear? So answer A is maximum is around 3.1 or 3, and minimum also if we use 750, if we let's say more, use correct wavelength. Okay, whole visible range, use topmost and lower topmost, so you will get this answer. Any doubt?
No, sir.
Okay, thank you. So let me ask one question here also. Let's say I have a material which band gap is lie in visible range. Okay, if I use infrared, this is infrared, that side, but I am using infrared spectrum for this material. Okay, but this has solar cell material. So infrared is useful or not for this material? Solar cell is give the output or not, please?
Sir, for infrared, it is not useful.
Yeah, because material didn't did not absorb. Band gap has infrared energy has less for the material because our material band gap lie 1.6 to 3 electron volt, and let's say 3 electron volt our material has. That much energy is required. Yes or no?
Yes.
So 3 electron volt infrared, let's say 1000 lambda equal to 1000 nanometer. What is the energy corresponding this? 1240 divided by 1000. How much? Only 1.2 electron volt. Yes.
Yes. Yes.
So this is not sufficient energy to excite the electron from valence band to conduction band. Okay. Next, elevation angle or latitude angle. What it is? Which of the following is the angle between the sun ray and its projection on a horizontal plane? You can see in picture also. For latitude 5, longitude lambda, measure for a spherical model. These are the diagram. And now read the question. Which of the following angle between the sun ray and its projection on horizontal plane? Sun ray and its projection on horizontal plane. You can see here, this is the sun ray and its projection on this horizontal plane on earth. This is angle. What is this is angle? You can see in simple ray diagram. This is horizontal plane and this is the sun ray, known as, what is this? Are you able to see?
Yes, it is altitude.
Yeah. So answer is latitude.
C. Yeah.
Answer C is correct. And let me show you one beautiful animation. 1 minute. Yeah. You can see declination angle. We have solved the question, but let's see the animation. Are you able to see animation? In mid, the sun and our earth is rotating like that. So our declination is changes from 0 to 23.45 minus to plus. You can see our earth is axis is also tilted. Are you able to see tilted axis? So in next picture, declination angle, you can see and this is formula we have used to calculate a question. Okay, if you are not able to visualize, you can visit this site pveducation.org. Okay, so let's discuss next question. Sorry, like that we have a azimuth angle also. What is this? How we can measure? Are you able to see this? Yeah, our Earth has North Pole, South Pole, East and West. From North Pole to the shadow of the sunlight on the horizontal plane, this angle is known as azimuth angle. So imagine this angle also, and formula for this. Let's discuss next. Declination angle we have already seen. This is formula, and so the approximation value of the solar declination angle on January 27th of 2025 today. What is solar declination angle today for our Earth? Please find this quick, and you can use this expression. What is n equal to? What is n? 27. Please answer me. You have a 2 minutes. What is the answer? N equal to, you can use 27 and you use 3 by 7. 360. 365 multiplied by 3. Taking some. Sorry, also multiply by 23.45. This will be 21.27 minus. So answer is, let me correct also, not this, minus. Okay, are it clear to you? Any doubt? There is some error in typing error. We forget multiply by 23.45. Clear to you? Yes or no, please? This is answer. Can we move for next question? Samir, please check your decimal error. Next, let's say the value of the hour angle at 4 p.m. local solar time is, and you can use this formula. So our angle converts to local solar time into the number of degree which the sun move across the sky. By definition, the hour angle is 0 at the solar noon. Since the earth rotates 15 degree per hour each hour away from the solar noon, corresponding to the angular motion of the sun in the sky of 15 degree. In the morning, the hour angle is negative. Afternoon, the hour angle is positive. So at 4 p.m., LST for 4 p.m. What is? Okay, clear? So this is the solution. Answer is correct. Let's discuss next question. What is the value of equation of time in minute for a location in Goa? This is the latitude angles on January 27, 2000. Today. Answer C is correct, but how? So you can use this equation. Please solve. This is wrong answer. Please find the mistake in this solution. This is right or wrong? Please tell me. You have 2 minutes. Please solve by yourself. This is right or wrong? Please tell me. Yes, please. This solution is right or wrong? You can check the error. If not, then right. If error, then wrong. So let me check. This is the expression. Then n is January 27 is right, and b is 360 by 350. So calculate b. Let me check also b. 27 plus 24. And this is 306.74 almost. Yes, please. So this is multiplied by 2. This is also right. And then sine 2b. This is good. Okay, this is right also. Okay, in minute. This is minute represent. B is this and 2b sine. Minus 0.7. This is also right. And what is else? 306. If I multiply, I will get 3.60 in plus the 7.53 multiplied by 0.4211 3.170 minus 9.87 multiplied by 0.7693. This is also minus 5.3. Minus 5.36. This is around minus 9.4. Yes, this is right. Where is the problem? Sorry. So this is the right answer. Anyone has doubt? Please check your calculation again. This is right. I have cross-checked. Okay, so let's move for next question. Next question, the maximum day length on today in Kanpur, located at the latitude and longitude at angle 26.45 north and 80.33 east, represent will be. You can use this expression, maximum day length 2 by 15 multiplied by cos inverse 10 delta n phi. What is delta n phi? This is declination angle. So how can you calculate? We have already calculated in previous slide. Let me, yeah. Sorry. This is okay. So use this expression and also, and what is phi? So you have to find delta and phi is given. Then put this expression and find the maximum length. Please solve this question. You have a 5 minutes for this question. Please try. After 5 minutes, I will solve this question. Okay. For delta, what is the expression? What is multiply? We have already solved this question.
360 upon 365 into n plus 284.
Yeah, good. So, if you know, recall this equation, please also. 360 divided by 365 and plus 20. And what is phi? We have already 1 minute. Let me show you in picture. Yeah. Phi is latitude and longitude is lambda. Okay. Phi represent latitude. This is represent phi, and this is represented by lambda. This is latitude. and this is longitude. So let me come to question. What is phi now?
What is 6.45?
Yeah, this is also given respectively. So use this value in this expression. Please tell me the answer. And there is no correct answer because I think delta is previously also not multiplied by minus 0.9 something else. So I forget multiply this. So also I think is assume here. So you have to find the right delta, use this delta, and please tell me the right right answer in minutes. This is simple now, I think. Minus 10 of delta. So what is delta? Declination angle, please. And 10 of what is 26.45. How much this delta? You can use 23.5. This 311, I think. What is this? This is also, this should be some. Yes, 65. This is minus 0.907 and multiply by. We have already solved this way. Use this delta in degree. Please find the cos inverse and multiply 2 by 15. 2 by 15. Yes, please answer. What is this, please? Guys, are you there?
Yes, sir. Yes, sir.
So please solve this equation. Let me, sorry. Why is I'm doing this? So this is wrong answer because we have used wrong delta, but delta is right. This 0.9 around multiplied by 23.45. Then expression this. Please find. Okay. So solve this equation, nothing else. Okay. So this is wrong answer because we have used wrong delta. Next question. The value of the direct component of sunlight throughout the day is given as. Which option is correct? If correct, then you can use this expression. Which one is correct? 4am 1.5 and find the correct answer. Let me tell you the right answer for 13. Then please solve this 14 question. This is the expression. Use this expression. Put am equal to 1.5 and solve for this am 1.15 and calculate the IH. Direct component of sunlight throughout the day. Yes, please. You can take 5 minutes for this question. Yes, please. This is the 1.5 you can use to the power. Please solve this first. Yes, please.
854.78.
Okay. So you are right. Yes, thank you. So this is simple expression you can easily solve if you have calculator. Next question. Plot the radiant power density with respect to the number of days for outside the Earth. So this is the expression you have to plot IS versus N for this expression. You have to take N equal to 1 to dot 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 365. Then curve look like how? Please tell me. Let's say N equal to 1 or N equal to 365. This is easiest, I think. So as IS equal to 0.33. This is cos 360. You can use. How the function look like? Let me multiply by this. Cos of function n, let's say s. So this is the constant number. Somewhere look like and multiply by also. So cos vary from to where? How we can? Cos 0 is 1. But this curve is shifted to the position somewhere here. Look like same cos function, but the position. Please find the position. This is position around maybe. How can you get this? This position, use maximum, cos maximum. So this number please add and cos minimum you can add. This is around. This is y position. Function where is like cos x, but shifted to this much value in y-axis. Okay. So this is, I think, last question. This is not 13, this is 15. Okay, so thanks for your kind attention. If you have doubt, you can may ask in next class. Okay. So thanks to everyone. We can
Thank you, sir.
Okay, we can meet again on next Monday.
Right, sir. Thank you.
Okay. Bye bye. See you on next week.
Right, sir. Bye.